Just as a quick exercise, we take this ellipse, and of course this ellipse is down in the plane, and just for simple practice, we know that the binormal vector's got to be the z, either positive z or in the positive z or negative z direction. It's going to be k or negative k. And it's going to simplify things quite a bit. Okay, so we want to find the osculating circle for the t equals pi over 6 point. Okay, well, how do we do that? Well, r of pi over 6 is going to give us the coordinates of our point, 3I plus 3 halves j, square root of 3I plus 3 halves j. If I calculate correctly, cosine of pi over 6 is square root of 3 over 3. 2 times that's the square root of 3. Sine of pi over 3, pi over 6 is 1/2, and 1/2 of 3 is 3 halves. I think that's right. So at the tip of this vector, which would be at the point square root of 3, 3 halves, we'll have an osculating circle. Now this is an ellipse, semi-major axis of 2 in the x direction, 3 in the y direction, elongated this way, and we're out, between, if this is the x-intercept and this is the y-intercept, we're about here. So from the origin out to here. So you can visualize that, you can make a little sketch of it, and you can sketch what you think the osculating circle might look like. If you're pretty good at sketching, you might come close. Anyhow, okay, there's our point. Square root of 3, 3 halves. Our velocity vector, well, we take the derivative, and of course I didn't write out, but the derivative is going to be negative 2 sine ti plus 3 cosine tj. Sine of pi over 6 is, careful, 1/2. And the cosine of pi over 6 is square root of 3 over 2. So we have negative the sine, have negative 2 sine t. It gives us negative I, and the other gives us 3 square root of 3 over 2j, and you can figure that out. It's very simple. The acceleration vector, being the second derivative, I believe it's going to have the same coordinates as these, because you just have a cosine of t, a sine of t. The chain rule doesn't change the constants, so your a of t vector is going to be negative 2 cosine t minus 3 sine t, negative 2 cosine ti minus 3 sine tj, so that a of pi over 6 is going to be this. It's just going to be equal and opposite to r of pi over 6, again, because you don't have, you just have a bare t in here. And I'm not making great sense with some of my comments, but it's getting late, getting hungry. Okay, so a of pi over 6, we get this. Our unit tangent vector, what? We divide this vector by its magnitude. Negative I plus, there it is, divided by its magnitude. And I think its magnitude is the square root of 21 over 2. You can verify that for yourself. I did that in my head, so don't take it to the bank or anything. Okay, so your a parallel vector is what? It's a of pi over 6 dot your unit tangent vector. In other words, your acceleration vector at this time dotted with your unit tangent vector. Okay, we went over why that is. And your a perpendicular then is a minus a parallel. And, calculate that. This is an easy calculation. This is an easy calculation. Your normal vector, you take whatever you get out of this calculation, which is your a perpendicular, and divide by the magnitude. Now, it might be a little hard to read, but we know how to do that. Your unit, your binormal vector is t cross n. You do this, you cross with this. These are unit vectors. They're perpendicular. They're in the xy plane, so you're going to get a vector out of the xy plane. It'll either be a unit vector k or the unit vector negative k. And rho, your radius, is just what? The square of the magnitude of your velocity vector, this, square of the magnitude of this, divided by the magnitude of your A perpendicular vector that you calculated here. So there's your radius. Here's your normal vector. So from this point, you go in the direction of your normal vector for this distance, and you have the center. And then you do these two conditions to get the equation of the circle. Okay, that's all we have time for today, but that's a big picture. So take that, work on it. It's actually not something that's assigned until next week, but it does a nice job of summarizing all the stuff that's assigned and due next week. Okay.